Hello everyone. In this video I am going to show you a C code that does permutation in a recursive way, and I am also going to show you the tree structure of this permutation and also the RAM diagram. How does this code works inside the RAM? So first of all, let me show you. We are having two functions here, and these are the prototypes of that functions. One function is swap and another function is permute. So inside the main, what is happening is we are going to take a string which is char data type, and this string is an array. Here it is an array, and inside the string is ADC. This is our string. We are going to find the permutations, the value of the permutations of this string ADC. Another thing is, we are going to save the whole length of this string, that is star len, inside this variable n, integer n equals to star len. Then we are going to call this function permute, which is going to permute this string, and in this function we are taking this string, this 0, this is the starting index, and this n-1 refers to the last index, or this C of this string. It is so because we know the length of the string starts from like this ADC and then \0. So here n-1 refers to this C, or the last index. Then it will return the values of permutation. So inside this function void permute, we are taking char star A as the string. We are naming the string as A. Then we are taking two integers, integer L and another integer R, which refers to the starting index and ending index respectively. So sorry, if this, we are giving this if else condition here. If L, which is the starting index, equals R, that is the ending index, if the starting index equals to the ending index, then we are going to just print the string, that is A. We are going to print this ADC. And if not, else what we are going to do, we are going to initiate a for loop and start the for loop iteration from I equals to 1, that is from the first one A. When I equals to 1 and until I is less than equals to R, that is the ending index, that is n-1, which is C, we are going to increment the value of I. And what we are going to do here is, first of all, we will swap AL, which is the first value, with AI, and in the first case AI is A. So first of all, we are going to swap A with A. What we know about swap is just interchanging or exchanging the values. We will take this x to y and y to x, that is, we will swap here A to A, which stays as A, and after that we are going to permute. We are going to print that permuted value, or that is that ADC. Again, then we will swap, and this will continue until I is less than equals to R. Here R is C. Until it is C, this process will continue, and in the last case, when L is equals to R, that is ending starting index is equals to ending index, then we are going to print the whole string. So that's it. Now I will show you the tree diagram. So let's see. The given string is ADC. First of all, what I'm going to do is, I'm going to swap this first index with this A, that is, I'm going to swap A with A. Swap A with A, and it will become the same thing. If we swap the same thing A with A, it becomes ADC. Then what I'm going to do, it will iterate to the second position, and then I will become and this will come to the second index D, and swap A with D. Here we can see in the code, that is, we are going to swap this AL with AI, and here the I is now it is D, so we are going to swap A with D and it will become DAC. A comes to the position of D and D will come to the position of A. Simple. Then we are going to swap here, the index I will be equals to C. Then we will swap A with C, and as a result it will become C will come to the position of A and A will go to the position of C, C, D, A. This is the first case. Again, in this case, what we are going to do, first of all, we are going to keep this A fixed, and then we are going to make change with this D. And first of all, I am going to change inside the code. We can see here it is written that then after that permutation we will iterate to the second position, and then we will start permuting again through swap function. So what we will do, we will first of all this D will be swapped with this D, so D with D. After swapping D with D, we get the same thing, A, D, C, and after that it will go to the next position after iterating. Then we will swap this D with C, swap D with C, and this will become A, C, D. They will come to the position of C and C to the position of D. And in this case, what we are going to do is, first of all it will go to A, then we are going to iterate, swap A with A, and we will get the same thing, DA, C. And after that it will go iterating, after iterating it will go to the position of C, and we will swap A with C. After swapping A with C, we get D, D is fixed here, CA, D, C, A. So these four values are found, and then what we are going to do, we will, in this case we will keep fixed the C, and changes will only come in this T and A. Here AL is D, the index is D, it will start from D, and after in first iteration it will be swapped with D, so D will be swapped with D, and after this swap we will find the same thing, C, D, A, and in the second iteration we will go to the A. This AI will be then equals to this A, and then we are going to swap D with A, and what we will find after swapping D with A is C, A, D. So here is the main tree diagram that we have drawn, and it is ADC gives 6 permuted values, and inside one permutation there are another permutation in each case, which are nested permute functions. And in this for loop we have shown all these things, that it will first of all it will swap, then permute, and this process will keep continuing. So we have drawn the tree diagram which gives us 6 permuted values. Now I am going to show you the RAM diagram. So first of all, there is, what we see in this tree diagram is, first of all there is ADC, the taken string. This is initial ADC. Here no values, nothing is fixed, so L is 0, and here R is 2. L is 0 and here R is 2. Since we will iterate this 2 times, so R is 2, and there is initial ADC. So first of all, we can see here we are going to the first for loop and after that we are going to perform a swap function with the first value, that is AI will swap with AL. Here AI is A, AL is A. So we are going to swap A with A. So in this first memory, swap A with A. In the second memory, this is the second memory, we are going to swap A with A, Nothing is fixed here, and here L is 0. Here L is 0, and it is 2, it will remain 2, and after swapping A with A, it will stay ADC. The same thing, it will go from this first memory to the second memory, and in this way. Then what we are going to do is, we are going to iterate the second time, and here A will be permuted with D. Since A is fixed here, fixed is A is fixed here, so it will become 1, and R will stay as 2. And after iterating, after swapping, now we will swap D with D. We will swap D with D, it is so because after A is fixed, it goes to the second, after second iteration it goes to D, and after this for loop it will become ADC after swapping D with D. So after this, when it is printed, it will give a backtrack because it goes to the primary ADC and again it swaps D with C. So it will go to the backtrack and come to the second position. Here it is backtracking. And this will be removed from the whole diagram. This will be removed, and from this ADC, we are going to say that this AC, here AD is fixed. After that AD fixed. After this second memory, AD will become fixed. After AD is fixed, it will swap with the third position. That will, after iterating inside the for loop, it will go to C and it will swap D with C. And after swapping D with C, it will become A, C, D. And then it will stay as 1, 2. The value of L will be 1 and value of R will be 2. So after that, we are going to the next and the last one, where we have fixed two things which are A and C. AC are fixed. After this level, AC is fixed. So as we are fixing two things, there will be 2 and the value of R is 2, and it will give us back this ADC, and only the first branch is done, and after that it will do backtrack. It will come back to the second position. It will finally come back, and after doing this backtrack, it will come to this position, and when it comes to this position, it will come to this position, and it will go to this one, and this process will be continuing up to it comes to produce CAD. It produces ADC, it produces ACD, and after that it will produce DAC when the permutation occurs with A and A in the second branch, But we will stop here. After doing this ACD, we will go back to ADC, and then ADC will again start from this, doing this second one. So here is our RAM diagram, and here is our, the backtracking here, and here is our tree diagram, and here is our main code, which will finally stop after printing those 6 permuted functions. So thank you everyone.